Now we're going to talk about radiation pressure of the electromagnetic wave. In the previous video we saw the Poynting vector S that represents the energy flowing through a square meter in 1 second. This is the electric field cross product with the magnetic field divided by mu naught. The reason for which we like the notation with the cross product, even though it is not necessary because always the electric field and the magnetic field are perpendicular, is because this cross product gives us the direction of the electromagnetic radiation with the right hand rule. So for that we use the cross product just to indicate the direction. Now it's usually thought about the Poynting vector as the average Poynting vector, or the average energy per square meter per second, because it is not always the same in the time. So we take the average value of that. Now, because the electric field varies with the cosine of omega t, and magnetic field varies also with the cosine of omega t, the Poynting vector varies with the square of the cosine of omega t. So the minimum value of cosine square is 0, the maximum value is 1, the average value is 1/2. So the average value, or average time for the Poynting vector is 1/2 of the electric field cross product the magnetic field divided by mu naught. And this is with what we usually work. Now, Einstein said that the photons have momentum, or momenta, each one. So the momentum of a photon, momentum, is equal to the energy divided by the speed of light. So the Poynting vector is energy per square meter per second. If I divide both of these by c, then I have energy divided by c is momentum. So I would have momentum per second, and here meter square, equal to the Poynting vector divided by c, or the average value, whatever it be. The change in momentum with respect to time, that is what we have here, is the force. Remember for mechanics that whenever we have a change in momentum, the P in the T is a force. So actually these are units of force. And force divided by area, units of square meter, are pressure. So the pressure, or radiation pressure, is the Poynting vector divided by the speed of light. Now, what is the pressure and radiation that we could feel? We don't feel the pressure radiation, for example, of the sun, because it is too small in quantity. But this is the idea. Look. First, from mechanics, let's suppose that we have here a wall, and here we are throwing to the wall 1 kilogram each second, each one at the speed of 5 meters per second. So in 1 second, the force that I would be feeling here, if I'm the wall, would be 5 newtons. And this is just conservation of momentum. Here at the beginning, I had 5 kilogram meter per second, because I had 1 kilogram per second that will advance 5 meters. And when it goes to me or to the wall, I'm feeling that 5 newtons. So I am absorbing that momentum. If instead of the tomato, let's say that instead of just colliding with the wall and then go directly to the floor, it reflects. For example, if we throw a little ball to the wall, it will reflect, it will come back. So in that case, the change in momentum is twice. So in that case, we will have a change of 10 kilogram meter per second. And the force that we would feel would be twice, because it's the force that we are, the force that we will need plus the force that is needed to return again. In that same way, the pressure radiation is not just the Poynting vector divided by the speed of light. Actually, is times a constant or a factor, let me call it alpha, when alpha could be 1, 0, or 2. 1 is if there is absorption, complete absorption. 0 if it goes transparently, and 2 if it reflects. So actually this is the pressure radiation. Examples of pressure radiation are, one example is a comet has two tails, one that is blue and the other is yellow-white. The yellow-white is due to pressure radiation, and the blue is due to excitation of some molecules, and then the excitation leads to emission of this blue light. But the yellow or white tail of that is easier to see of a comet is due to pressure radiation. So the pressure radiation is just the Poynting vector divided by the speed of light times the factor alpha. The factor alpha will be 1 if there is complete absorption, 0 if it just goes transparently, and 2 if it reflects.